Dan wil ik eigenlijk over naar Anukool. So I'll be speaking English because Anukool will also be presenting in English. He will be telling us about the HAS at Helsinki University. It's also a case actually that is was presented to the board of Santeon, and it inspired the board also to have a central platform. So that's one of the reasons why we have HIPS. Anukool will be giving a presentation, a demo about the HAS, and I will be asking Anukool to introduce himself to you. Anukool is also engaged in our process for the central platform, so he is also informed about what we are doing as Santeon. So I don't know if you are ready, Jos, but Anukool is on mute, I can see. I think he will be able to speak to us.
Can you hear us, Anukool?
Now we can see him. Hello, Anukool.
Yeah, I hear you clicking.
So shall I go ahead?
Yeah.
Are you? Did you
Okay,
hear
all
the
right.
introduction?
So good morning, everyone, and I hope that everybody is. It was a very good session from Bram earlier today, where he spoke about the vision on value-based healthcare and how he plans to architect the entire system. And I'm now going to talk a bit about one of the customers who started with the vision of developing an international level hospital organization that produces new information, consumes it in a very high quality way, and basically produces a lot of competitive services for citizens and hospitals and units. So just to introduce myself, my name is Anukool, and I work for Microsoft's Western Europe healthcare team. We focused completely on healthcare customers, and we work all across Western Europe, on very, very specific, customer projects like value-based healthcare, like the advanced data platforms, advanced, AI for patient engagement, operational analytics, and so on. So, so this particular case about HUS, HUS was a joint authority which was formed by 24 municipalities. They have around 1.6 million residents, operate in 22 hospitals with approximately 3,000 beds and 2 billion, US dollars of revenue. And they are one of the largest employers in Finland, they are sort of having an average age of 43.7 years, among their employees. And what they wanted to do is they wanted to use, the data and the real-time data and insights to impact the well-being of patients. They wanted to be more closer to their patients, what is happening with their patients in the real time. And also at the same time, their main intention for their internal employees was to take off a lot of stress which comes to clinician because of managing both the patients and also entering a lot of information in the IT systems. So prevent the patient burnout, physician and clinician burnout over a period of time while they are engaged with patients, because it's very important that our clinicians and the nurses, they are sort of not given a lot of additional overhead in terms of IT, in terms of entering information into the electronic medical records and so on. So so that was their vision, and then in around approximately in 2016 is when this project started. when the CIO of HUS, he came up with a vision that he wanted to combine all these different areas which were evolving since 2012, and they were going towards 2018, and he wanted to create a centralized data platform which can help them achieve their vision of one of the best international data platforms with a lot of patient centric services, and also with a lot of which takes off a lot of burden from the clinicians. So they wanted to go with a centralized data platform. So what the CIO was thinking is that he went to this greater Boston area where he saw the alliance between the Harvard Medical School, the MIT, and the MGH, where in the greater Boston area, where there were a lot of university and industries which were forming an alliance to improve the health and well-being for the patients, and also work a lot on the well-being technology for the patient ecosystem. So he wanted to develop a similar ecosystem in the Helsinki as well, where he wanted to use HUS. He wanted to use the university hospitals and the IT companies which were operating in the nearby region to form a health technology network to tackle these challenges around patient care, and also around physician and clinician and nurse burnout and so on. So this is at a high level their architecture. So at this point in time, they have a centralized data lake. And then you can see that over here, in blue, at least I see them in blue. I'm not sure whether there is some other color which is coming on your screen, but typically they had these various different systems of records, which we call that, which are like the electronic medical records, the data from the public health repositories and health accounts, and the data from the mobile health data, which is a virtual hospital or cancer and diabetes monitor data. So all this data, from EMRs, from genomic banks, from environment and public health systems, they are ingesting that in real time, using Azure's services onto a centralized data platform. And this centralized data platform basically, then ingests this data, it processes it, it cleans it, and then it is sent to other, downstream applications and also to the individual patients who can access their own records, who can see, how they have been diagnosed, what kind of treatment and the care pathway are they following, how they are going to be, moving into the hospital with respect to appointments with various different physicians, with various different subject matter experts, and so on. And this also gave them, the medical personnel to be more closer to the patients, because now patients could also, using their data, they could talk using technologies like virtual consult to their physician, and they can sort of get a very personalized treatment support and prognosis from the medical personnel. And medical personnel also, they were able to take this data, combine this together, and then they were also able to collaborate with other different physicians, who were, let's say, not present in Helsinki, but maybe, working somewhere outside the city, 500 kilometers away in a different hospital, but carry that subject matter expertise, and they would like them to sort of, look at this data. Then another, use was the researchers. So researchers were able to, create new protocols of, some of the diseases for which there was no protocol existing, and there were a lot of patients who were sort of suffering because of, not having a very specific, protocol for a particular condition. So this was sort of a high level, their well-being and information ecosystem. I'll just start to get into a bit of a detail of that. So this particular view also, is a very similar, where their data lake is a very centralized data lake, and it uses a lot of data from EMR, quality register, near real time, the finance and billing data also comes in. And later on, they also started to, ingest medical images. So the ones in yellow are the boxes which started, in phase 2. They started with all the orange boxes, in the phase 1, typically because of the fact that that some of the extracting data from some of these systems was easy. And then typically EMRs and PACS, they require, a lot of data standardization in terms of data models and so on. So, typically that exercise of deduplication and standardization, it takes a bit of a time. So that was some of the challenges that they were facing at that point in time. But like you can see, this is centralized data lake is the one where they have all this data ingested, and then once the data is standardized, it is cleansed. Then they also send us to the other different systems which help them do analytics, modeling, algorithms, and predictive analytics. And then this data is shared with the physicians, nurses, researchers, and so on, so they can use these advanced AI and machine learning algorithms to do a better patient care and use them in their research, use them in their day-to-day work to improve the processes within the hospital or to improve the care that they are giving to the patients. So this particular data lake, as of today, it has more than 500 terabytes of data. They get real-time data, from various different hospital systems like electronic medical records. They get real-time data from ICUs, and that helps them make real-time decisions, on the fly if there is something more needs to be done for a particular patient. These are the building blocks of their data lake. So like you can see, I'll start from the left. So they have first, the domain specific certification. So what this means is that anytime when we start to use cloud, all the technologies that are, on cloud, or whether the devices which will be used to communicate information, they should be certified. So, so most of their, devices and most of their equipments were already certified, and then they procured additional certifications for using the cloud technologies and some of the systems. And then the another aspect very important is the security and privacy. This is very, very important in the healthcare world. So in this, they focus specifically on access and identity management, wherein you decide who all should have access to the data platform and what level of access, how the identities are set up within the cloud. Then pseudonymization of patient data was another one, where any data that comes onto cloud should be completely anonymized and pseudonymized. So there should not be any leak of any particular patient information. Then another one was the audit. So anything that you put on Azure or any activity that you do with data should be auditable, like who did it, what time it was performed, and who had access to data, who tried to do what kind of activity. And finally, there is a GDPR compliance. So they always ensured and did an assessment that whatever architecture that they are putting on Azure should be completely compliant with GDPR. Then they had these infrastructure services. Infrastructure services are primarily related to the compute, storage, and networking. So like some time back, we saw a demo from Brahm, and he talked about Azure Databricks. So Azure Databricks is one of those compute services on top of which uses Apache Spark to do the computation. So likewise, who's used Spark, and as well as the distributed file systems, and also the Azure SQL databases. So they used a wide variety of infrastructure services depending on the nature of data that was coming from their systems. And then for the data integration and processing services, they used a wide variety of technologies like FHIR, the OMOP data models primarily. Because FHIR is a golden standard in industry, and if you want to make any system interoperable, where you want another parties to exchange the data with you, then it's very important that these two systems are able to handshake together, and they understand each other very well. Otherwise, those two entities will have a lot of problem in exchanging the information. So FHIR is one technology which simplifies that particular interfacing. It standardizes the resources which are present in the electronic medical records, and they were able to sort of make use of that in able to exchange the information easily. Now, for a lot of data which it needs to be stored in a history and which comes in a batch format, every day or every week within the hospitals. For that, they were using OMOP data models. So OMOP data models typically are also very, very well standardized by OHDSI network. And they are, using OMOP data model within their data lake to store a lot of historical data in their data warehouses and then exchange that information with other university hospitals and outside also, with other countries like Lithuania. Then in terms of, sharing or utilizing the data, they have built a lot of open data APIs, which these APIs can directly read data from their data lake or from their analytical databases, and then can give these data to the researchers and so on. Now, one very important thing on which you see on the right hand side, this box called managed services. It's basically how you create various different instances, how you deploy your IT environment, and how you automate the delivery of your data lake on your infrastructure. So they do not use any of the manual intervention. They have built their own DevOps pipelines, using which they can monitor, using which they can continuously deploy the migration of the code from one environment to another, and they can also govern it. So there is no manual intervention which is done over here in terms of people manually migrating any code from one environment to another. People only review the code, they only give approval to the code, but most of the infrastructure creation and most of the data migration from one environment to another is done using DevOps pipelines. So that these are basically the building blocks of their platform. And then once they have established these foundations, then they have created some very specific applications on top of this data set, applications like HealthBot or Patient 360, where they are able to view how a patient has evolved during a particular care pathway. And then they have smart analytic services like tools like Power BI, where they are able to do data aggregation, the operational reporting, and also the output of machine learning algorithms they are able to display. And then finally, the third-party services. So these third-party services are the ones where they have created what they call as intelligent healthcare network. And there are a lot of organizations which are using this data to develop more and more healthcare products for the customers or the patients, and also for doing the advanced level of research with the organizations like MIT and organizations like Harvard Medical School, who are leveraging this data to carry out their research practices within the region and find out what kind of policies government needs to come out with in order to improve the patient services. This particular slide talks about their data lake. So in their data lake, they have done a sort of a logical organization, I would say. So the logical organization of their data lake in terms of data presents them with three different views. And the reason why it is important to understand why they have three different views is because of the fact that these different types of decisions require different types of privacy design. So for example, if I want to use any patient data for research purposes, I need to have a consent from a patient. But at the same time, if a doctor wants to use some data in the real time in a clinical setting, then he should be able to act on a patient in real time as the patient situation is evolving by looking at the data set. And operational view is an aggregated view which gives the hospital administration a view of what is going on in real time and how the patient is evolving in the real time, how the operations are doing, whether the operations are being performed in in a way which is extremely patient-centric, whether all the processes or all the activities that were supposed to be done on a particular patient, or all the care pathway activities, whether they have been performed on a particular patient, or all the procedures are carried out successfully, and what is the outcome of those procedures, whether there were readmissions and so on because of this. So that sort of a view, comes to them in an operational view, and they have basically logically and also physically segregated this entire view within their data platform. And then this is just a detail on what kind of researchers tools are being used in the research data lake. So what happens is that in the research view in particular, they have extracted a lot of data into their research data lake, and then they have a wide variety of tools like R, Python, SAS, which run on top of this research data lake. And this research data lake uses dashboards for creating the cohorts and identifying patient, and basically they get the history of entire patient and try to study what kind of profile that patient has, what kind of they also get the information from the sequencers, and based on their DNA profiles, they start to build a very specific, precise treatment for a particular patient. So this is their vision towards going towards precision medicine, that they will extract all the information about the patients and their genetic makeup, and then they will run analytics on top of it, and then they will come up with specific, patient care pathways. And all the high dimensionality analysis and the high throughput analysis on sequencing files, is being done in this particular environment. And then, the output of this genome analysis is also produced to the researcher in a very standardized format. They have created their own data visualization services using some of our partners, and then they are being consumed, those services, by these researchers. And then, like you can see on this particular slide, so other than that, they have their vision is completely now towards evolving towards a data-driven, hospital. So what they are also able to do today because of this data lake is they are able to take a lot of services outside their hospital. So, for example, if today they want that a patient, is very old and he cannot come to the hospital, or he will be at a high risk when he turns into a hospital, they have the facility that the hospital can go directly to the patient. A patient van goes to the hospital, where from hospital to the patient's house, where patient is given a lot of variables to sort of monitor his cohorts in the real time, and then all this data in the real time comes to their data lake, and then the nurses using their contact call center can look at the patient's condition, can advise the patient on a particular condition, on what the patient should do next in the real time, without that patient having to come all the way to the hospital, or without that patient having to expose himself within the hospital environment. So all that particular thing could become possible because of the fact that they were using a data lake, and in their integration layer they had technologies which could ingest data in the real time, using things like IoT, using technologies like Fire, and the data could be standardized in a very quick time, and it was able to displayed for the nurses in a real time mode. So before this data lake was existing, at times there used to be 19 hours to a few weeks before this data could be made available for the physicians. But after they had implemented the data lake, this whole time became very compressed, and it came down to 19 minutes. And they still have this vision of reducing this time further and further, when they can look at how the patient is evolving almost in every second. And then this is basically the another vision that they came up with. It's called the Health Village. And the Health Village basically focuses on using this data lake to provide the best and the comprehensive e-health service and best of care for the citizens. So what happened is that they are sort of working on developing new services on top of this data lake, and they are supporting operational change in healthcare. And instead of just digitalizing old services by just new technologies, they are also trying to change new services, and these new services are the ones which they are trying to develop in order to just change the way some of the healthcare processes work. So, for example, if they were using, for geriatric purposes, the patients were coming to the hospitals and they had a particular care pathway where they had to visit every week to the clinician. Then what they are doing is that using this data lake, they are sort of trying to pack all of these services and take these services to the patient itself, and then using this data trying to develop new pathways for the patient care. And the Health Village basically has 30 different hubs. So they have classified their services into various different kinds of patient cohorts and various different kind of conditions. So for example, there is a health village for brain, there is a health village for heart, there is a health village for surgery, and so on. And then they are continuing to add more and more hubs into these health village. And what happens is that the data is used very, very specifically in all of these different conditions in order to impact the patient and their care for that particular condition. So, for example, if I have a health village which focuses particularly on vascular disease, then they will take the genomics profile, and then they will look at how various patients have benefited from a particular therapy which exists within the same cohort, and what kind of needs the patients have, whether there is some critical clinical information that is being missed, or whether there is some research aspects which need to be improved in terms of vascular diseases. So they basically analyze all these things, and they research on those common genomic profiles, and then they try to develop very specialized care pathways and very specialized care treatment for those particular hubs. And the good part is that initially when they started to invest in these hubs, they saw that there was an initial cost that was associated without using technology associated with giving these care services. But over a 4-year period of time, that cost has sort of started to come down. Now the cost of care actually has also come down for them quite significantly since the time they started to implement these various different health village hubs. I'm not going to go into very technical details of the health village hub as of now, but if anybody is interested later on, I can cover and provide more details about what the health village hub is. Then another thing that health village serves is a lot of patient-centric applications. These patient-centric applications are the ones where citizens first of all use them for their own proactive well-being, and then there are these applications which are used by clinicians in the real time for looking at how a patient is evolving. And then there are applications which recommend or which are prescriptive in nature, which prescribe to the customers what kind of nutrition they should follow, what kind of care they should follow, what kind of plans they should have for their health, and then these applications help them track those plans also on a daily basis. So for example, here, like if you look at the health nurse recommends this patient to enhance physical activity and manage his weight, and she guides him to start the weight control self-care path in healthvillage.fi. So what happens is that for diabetic patients, where there is a health hub, and then on that hub there is a particular nurse who looks at this patient, and she can actually give very recommended, very personalized information and insight to this patient, and then advise him what needs to be done next. If he didn't do any activity for past 5 days, or though that activity is less than the threshold of activity that he should be doing on a daily basis, then she can tell him that you need to do more activity, and can advise him in real time. So the good part about this health village is that it helps the patient to be connected better with the hospital, speak to hospital in almost in the real time, and yet not be physically present within the hospital. So that's one aspect or the one need of patient care that this health village hub satisfies. Another one is tracking down the activities. So for example, if somebody has been given a particular prescription in terms of activities and in terms of medications that a patient need to take after getting admitted to the hospital, and now while he's getting rehabilitated back at home, then the nurse can look at it, and she can advise him whether if he has missed some medication, then what he needs to do next, and if he's sort of missing his activity and he's not sort of feeling well, then nurse can talk to him and advise him to either come to hospital or just take any other proactive measures from her side, which she feels is good from a protocol perspective for that patient. So this is just the slide from the CIO of the hospital, where he wanted to go on a digital care delivery pathway. I'm not going to go into any of the large details of any of this, but what I wanted to sort of convey is that they really have a lot of focus on patient throughput and capacity management. This is primarily from the operational perspective. So, for example, they track in real time how many patients have been admitted, or how many are coming, every hour to the hospital, and what kind of capacity is available within the hospital, and whether they want to sort of do something in order to change that capacity in a way that whether they can free some of the hospital assets to reduce the patient queue which is lining up against some of those allocated assets, and so on. So like you can see in this particular dashboard, they are given two different timings, and what sort of a queue is present in each of the different departments. So that is something which they track in real time with their data lake as well. And then, their whole idea was actually to, this is more around, these are the vision slides, is to sort of pack the hospital into various different kind of services, and then, ship that hospital to the patient itself. So for example, remote consult is one, area that they saw. Lab analysis was another, maternity was another, and likewise, structural imaging was one of those, and they actually try to tie this all this different areas together to build more and more personalized Lego-like services using platform onto their hospital IT infrastructure. And then this particular use case is around that they are doing as of today is around sepsis as well. So, they actually extract the data from the babies and the newborns, in the real time, and they use their data lake and advanced ingestion services like HL7 and XML high speed. Within 2 seconds, it's streamed onto the Azure data lake. And then, from there, they are able to come up with whether a child is going to be having some sort of a sepsis. Because the challenge with sepsis is that if it is predicted really early, when you are when certain cohorts are giving you an indication, then you can still prevent sepsis, from happening at that point in time. But if it develops, then basically there is a long, care cost associated with that. But more than cost, it's like, the patient has to suffer from sepsis for a long time if that particular condition could have been prevented. So they basically have combined, some of the technologies like patient monitor and taken the data out of that, and using AI, they are able to tell in real time, within a minute whether a particular newborn or a patient will have any kind of sepsis, indications or not. And if there is, then they can act in real time. So this is just an example which I added in order to just show what kind of things they are possibly are able to do, because of the fact that they have a centralized data platform which can give them real-time insights. And like this is a dashboard, just a sample dashboard which they have presented, where they have categorized who are the most high-risk patients which are likely to get sepsis. And if they have that view, then they are able to act in real time, on those patients and give them a very, very personalized treatment. So, like you can see on this slide, the format of the data is still, HL7 and XML in some cases, which means that it's very important that in order to for data lake to generate these insights, they are using very, very industry standards. Industry standard data models and industry standard documents like XML, and industry standard resources like HL7, which can be integrated very quickly, with the data lake, and then can give the advanced, predictive insights. So, so that's typically it. But just last few comments on the Clever Health Network. So this is something which I mentioned earlier also. So Clever Health Network is basically a health technology ecosystem, which is in which companies and the leading healthcare experts, they are starting to use the health data which HUS has, and they are trying to develop better treatment solutions, and they are also trying to develop successful products in the field of health technology. And this particular ecosystem, has brought together very leading clinical experts, the health technology expertise of, Finnish subject matter experts and large corporations. I mentioned, MIT Health also, which is collaborating with them. And basically, because of this vast and internationally unique, high quality health data, they are able to, attract a lot of these researchers and a lot of these organizations to invest in the products and invest, in the better quality of technologies that they want to develop. So this network was established in autumn 2017 when they started the data lake in 2016 and 2017. They established the Clever Health Network, and right now, the companies like Microsoft, IBM, AWS, Google, all of them are sort of part of this Clever Health Network, and then they are trying to fund various different kind of research within the precision medicine or advanced imaging and so on. So all this could become possible because of the vision that the CIO had at that point in time, that he wanted to create a centralized data platform for these various different municipality together. So I think I would sort of stop here. It's already 10. And I am okay to I'll look at the questions that perhaps you have posted in Teams, and I will respond to those. But any point in time, if anybody wants more details and anybody is interested in how they went, they want to go into the details of the architecture, very happy to support. So so that's it from my side. Thank you so much for your time today.
For your presentation. We don't have any questions online. Are there any questions here? I think it was nice to hear from you, Anukool, some examples of what you could do potentially with a centralized data platform. I was wondering how many hospitals are joined in HUS, or is it just one hospital and that digitalized their healthcare? No. Anukool, can you hear me?
Hi, Ranske. Now
Hi.
I can hear you. Is there a question?
Yeah, we didn't have any questions online, but what I would like to thank you for the examples you have given us about HAS and what you can do with a centralized platform. I was wondering how many hospitals are conducting in this platform. Is it just one, or are there multiple hospitals, just like Santeon? Yeah, he can't hear me.
Yeah, now I can.
Oh, now you can.
Yeah.
Hi. How many hospitals are competing in of conducting in this platform? Is it just HAS, or is it just like Santeon, a network of hospitals?
So right now it's around 22 hospitals, and they also started to engage cross borders with Lithuania. And HUS is also part of the European Hospital Alliance, which is also being created right now between Erasmus, Karolinska, HUS, Hospital Sarafele in Italy. So there is a plan that all these hospitals, in future will start to exchange their genomics data, will start to exchange their clinical information to come up with more personalized treatments across Europe.
Thank you. We were also talking about the standardization of data. That's why we are together this week to talk about Santeon information model to exchange data in a more harmonized way. You also talked about that in your presentation, that it was really important. And I was wondering if you could share some information about how HAS took on this job.
Yeah. So mainly when they started to do this data lake job, they found that a lot of their data was not very well standardized according to the international standards like FHIR or like OMOP. So they had to do quite a lot of mapping exercise to begin with. So for their legacy system, if you want to bring the data into the centralized data platform, you will first land that in the raw zone as is, where you have copied the data from the legacy system into the data lakes, raw data or staging area, and from there you start to do a mapping of that data into a particular standard. It could be OMOP standard or it could be FHIR standard. Typically, for storing the data for historical purposes, if you want to store that in a data model sort of a format, OMOP is typically preferred. But if you want it to just exchange that using let's say APIs, or you want to build advanced patient applications using the technologies like JSON, or using technologies like XML or HL7, then you need to standardize that in a very, very clinical specification format, which is more like the FHIR format. And both these two standards they followed because their data was pretty heterogeneous in nature, and the needs of their applications was also quite diverse. So they created a data warehouse, which is based on OMOP data model. And then they created the data lake and the document repository. And on top of that, they ingested that data into the data lake after standardizing it into the FHIR and HL7 formats. So they used quite a lot of mappings. They used quite a lot of standardization frameworks. They used quite a lot of ETL technologies in order to standardize both these data models into their data lake environment. So once that standardization happened, then they also created the metadata and the data governance program on top of this data, which could see if a system is sort of having a poor data quality, or it's not giving you the right standard information that a particular specification like FHIR expects, then they could send that information back to the hospital, and then they could ask hospital to act on it. So for example, Recently, we found out when we were working with them that certain patient cohorts were missing. In one of the hospitals, we could not find out whether the patient is released or discharged from the hospital, or whether the patient has died. So those kind of cohorts were missing. So they could find that in real time during the COVID crisis, and they could ask the hospital to fill those in their electronic medical record and have those checks and balances. But OMOP and FHIR are typically those two standards. They enabled them to share this data with the other hospitals also, because once you have a right data model in place, what happens is that everybody knows, what different kind of specifications and the columns and their information means, and you can use a generic query on top of your data lake to generate the information or to generate a particular patient view, as I would say. That typically is very, very relevant even in value-based healthcare exercise.
Thank you, Anukool, for sharing your information with us. If there are any questions online or from us, you could send it in through database@santeon.nl, dus database@santeon.nl. Anukool will be able to answer some questions we have on a later date. So thank you, Anukool, for your time. And your to show us what you can do with a centralized data platform.
Yeah.
So thank you so much.
Thank you so much, Renske, and everyone. Thanks for the patience.